Yeah, hello everyone. Today we are going to be looking at the third aspect of exponential functions. The third aspect of exponential functions. So please, before we start this video, you can do the following. Ensure you click on that subscription button, that subscription icon. Please click on that icon, then click on the notification bell so you'll be receiving more videos from us. This is the best academy, and I'm to God's love installing my name. So please ensure you have subscribed to this channel. That is our energy. As our subscription keep going, we'll have more energy, more strength to do more videos. So this is the third aspect of exponential function. We call it exponential function 3. In the sense that you now have y to be equal to 2 function of x. Remember, the first one we did was just e raised to power x. The downside was e, and the upper side was just x. And the second one was a raised to power s, which the downside was a constant number, and the upper side was a function of s. But this third aspect now, both sides, the power and the base, are now functions of x. So I'm going to show you guys how to solve this question using two approaches. The first approach will be from the first principle, in which we come from product rule, so we'll get the answer. The second approach is when we are using this generated formula. I'll show you how the formula works, and look at it. If you have y equal to function of x power another function of x, which is f of x raised to power g of s, the derivative of this will be the question, which is f of x raised to power g of x times the g prime of x. What is not g prime of x? G prime of x means we should differentiate this g of x. We should differentiate that function. Then log natural logarithm, that's log 2 base e of this f of s. Then after you have differentiated this, you need to multiply the log of this downside, which is the base. Then plus differentiate this base and divide it by this same base, which is f prime of s all over f of x. Then the next is times the g of x, which is this upper side. So I come again. First is to write the question out. Then use to multiply when you differentiate the power. Use to multiply log of the base plus differentiating this base divided by this base. Then times this power is here. So when you see prime, we need to differentiate it once. You see prime, we need to differentiate it twice. That's how it is done. So please take note of that. So I'm going to solve this first example. Is if y is equals to x raised to power x. What will be the one by this? I'm going to solve it using two ways. Using this formula and using the other method in which we come from product rule. And we are going already. So please, let's kick on. So the first thing you do, if you don't want to use this formula, the first thing you do is to take the natural logarithm of both sides. So you take the natural logarithm of y, then you take the natural logarithm of x raised to power x. The next thing, you apply the rules of logarithm to this, the side that have power. Apply the rules of logarithm to the side that has power. This side have power here for this side, so we're going to have log y to be is equals to, apply the rules of logarithm here. Now, if you have log a raised to power b, the answer can also be log, that is b log a. The power will move to the back of the log. So if you have this power is going to go to the back, we're going to have x log x to base e. That's what we're going to have. The next, we're going to differentiate both sides. We're going to differentiate this side using implicit differentiation. We differentiate this side using product rule. So if you want to differentiate this side using implicit differentiation, we're going to have, since we are differentiating with respect to x, not with respect to y, we're going to differentiate this one and add the y over there to the back. Since we are differentiating y, not but we are differentiating with respect to x, that's how you do implicit differentiation. If you are doing implicit differentiation, and we are not using a shortcut, if you differentiate y, you must add the y over there to the back of your answer. And if you differentiate x, there's no need of adding y over there to the back of the answer. If you are differentiating y with respect to x, that's how it is done. So differentiating this, we're going to have 1 over y. That's the answer. Remember, if you differentiate log x to base e, it will be 1 over x. So differentiate log y to base e with respect to x, 1 over y, but you must add the y over the x to the back. This will show that we are differentiating with respect to x, not with respect to y. Then it's equals to, now differentiating this using product rule. Differentiate the first one, you have 1, then you leave the second one. Remember, product 2 plus differentiating the second one, then you leave the first one. X, then times differentiating the second one. We have two functions here. We have this and this. Differentiating this one, then you leave this, you have this. Then differentiating this and leave this. You have differentiating this, you have 1 over x. That's what we have. So this s, we cancel this x, then we'll be having 1 over y dy over dx to be equal to log, because 1 times log s will be log x to be c plus 1. So we'll be having there. So next, we're going to multiply y to the other side. So just multiply y to the other side, so that the 1 over dx will be free. That's like they're just making the 1 over dx subject of the formula. So the 1 over dx is equal to y times this, we have y times log x to be c plus 1. So that we now be having, remember that we can recall that y is actually, what is y? From the question, y is equal to s square s. So y is equal to s square x. So anyway, see why you put s square x. So the y over the x will now be equal to s square s times log x to be c plus 1. That will be the final answer. This is the first approach. What you do, take the log of both sides. The next thing, you apply the use of plugging in there, go to the back. Differentiate this one using this differentiation, differentiate this using product 2. And next, you multiply y this side, put the value of y back to where you see, where you are seeing y. So the next solution is to apply this formula. So let's try this solution. Okay, you can still have this question. If y is equal to s square x, dy over ds will be equal to. Now, applying this formula now, we just give you the answer directly without any further delay, without any problem, without any stress, without any complexity. So let's see, look at it. If y is equal to s square x, dy over ds will be equal to, the first thing you say, you write the question, s raised to power x times g prime of s, means you differentiate this function of s on top. So differentiate this s, we will have 1, then times log of f of s, times log of what is f of s, the downside, x to be c, plus f prime of s followed by f of s, means you should differentiate this and divide it by this same f of s. So differentiate this denominator, we have 1 over divided by this same denominator times the g of s. What is the g of x? The power y is what? X times x. So that the answer will be s raised to power x times log x to base e plus this, we cancel this 1. That will be the answer to that problem. You see, the formula looks difficult, but the solution is very short and simple. So this is what I use. This is what I use, but I do know how to solve it this way. In most textbooks, you're going to see it this way, but in my channel, you're going to see it this other way. So let's look at another question. Let's see if y is equals to s power 5x, what will be the y over dx? This question now, f of x, okay, let me write so that things will not be confused. So using this formula, dy over dx will be equal to this formula, that is s raised to power 5x times the differentiating 5x, we will have 5, take the log of the denominator, plus the differentiating denominator 1 over the denominator times the numerator. That's all. It's as simple as that. Using this formula. So we are going to be having 5 is common, we're going to come outside if you wish. Then x, we cancel x. So that we'll be having dy over dx to be equal to s power 5x. Then if you wish, you can bring out this 5 since they are common. That's 5 log x to be e plus is cancel this only 1 negative. That will be the answer to that. So when you are through this, you can try this number 2, then you can try this number 3. If y is equals to, let's see, s square 2x, so the answer, the over the s will be s square 2x times 2 bracket log x to be c plus 1. So we have, or we also have s power 2s, 2 log s plus 2. It's also possible that way. So we can also try this one number 4. If y is equals to s raised power sine x. Very good. S power sine x. So the answer over dx is going to be s power sine x then times cos x times cos x log x to this e plus sin x over x sin x over x. That's what you're going to have as your answer. Cos x log x to this e plus sin x over x. Please ensure you subscribe to this channel. This is what keeps us going. It's going to give us energy. Please also give us a comment. Have any comment at all, put it on our comment section. And love you. God bless you. I'll see you guys in our next class.